Good morning, everyone. Welcome to the third lifting solutions group webinar on steel wire ropes. The third one of our series. The first one was on basic of steel wire rope. The second one on special wire ropes, and we're going to talk today with my colleague here, Ellen Ballman, about visual inspection and discard. And we also have a part where we will speak about internal inspection, also magnetic rope testing, with my colleague Bruno Fusini from Italy. If you have any questions, please put them in the chat. We cannot do them during the webinar, but after the webinar we have 10 minutes left that we can do the Q&A with our two experts. And not all the questions can be answered, but we will answer them after the webinar by sending you an email. My name is Michel de Vos. I'm marketing manager for the Menace Group, and I'm hosting this webinar together with colleagues from all over Europe. And please note that you're on mute, so if you have a question, again, please type it in the chat. First of all, we have a small introduction about our group. We're part of Axel Johnson International, which is a large Swedish big company family that acquires companies from all over the world, and they have 6 divisions. I think the beginning of October will be 7, and we're part of Lifting Solutions Group. And here you have some numbers. Like I said, we're a global player, and we're specialized in steel wire rope lifting equipment and inspection, etc. And we operate as a group of companies, and we have we serve local clients, global customers in several industries. And as you can see, 22 companies in 20 countries, etc. Since last webinar, we increased our number of companies, and we acquired we acquired a couple of companies in Australia, 5 pieces, so we're growing and growing, and we have a good coverage, almost, not almost, but worldwide, very good coverage on lifting solutions. My final part is, I think, one of those logos you will recognize. Again, we all have a big presence, serving local and global customers worldwide. This is more just a small introduction about a company, and I think you just want to hear the story of Ellen and Bruno, so I will hand over to Ellen.
And a very good morning from my part also. I'm Alain Ballman, and I would like to teach you something about visual inspection discard. There's a slide not coming. Okay, thank you. Okay, so I'm Alain Ballman. I'm industrial engineer chemistry. Yes, that's another story how I became then into steel wire ropes. I'm at the Belgian Menace in Antwerp since 86 already. So they say I'm a senior wire rope specialist. Well, I hope I will. I advise people, do some investigations, and yeah, we want to do service live reports, and we have our lab also in Antwerp to do some investigations if needed. Yeah. So, okay, let's start with discard. The subjects of the webinar will be like this: inspection of wire ropes, why and when and who. We're gonna introduce you to the discard criteria, the rules that apply, standard rules, let's say for all over Europe, because we're all over Europe now. I'm gonna introduce you to the rope category number. What is it? What can we do with it? And then afterwards, then my colleague from Italy, Bruno, will take over, and he will explain you what we can see into the ropes with the magnetic rope testing, how it works and how it could be an advantage for you. Okay, let's start with inspection and discard of steel wire ropes. As I mentioned in the earlier seminars, yeah, a steel wire rope is a consumable. That means that it will last for some time, but you're certainly going to have fatigue in your rope. You're going to have, yes, let's say wear outside and inside. You're going to have sometimes deformations due to fleet angles in your system, and sometimes you're going to have rusty situations, so oxidation. And at the end, you're going to have to discard your rope, put it out of service. And when you need the inspection, well, that is depending on in which country you live and you do the inspection. So each country has its own Labor Act, where there's a regulation how to inspect, when to inspect, how many times to inspect, who's going to do the inspection, who's going to do the monitoring. The UK has left Europe now, but they have or will have their own Health and Safety at Work Act. So wait and see what that will do. So when it depends on the country. What? Well, he who's doing the inspection has to do the whole length of the rope. Also the end terminations, he has to look at the sheaves and at the drums, yeah. And one very important lead into this is the ISO 4309. So this is a standard procedure where we're gonna talk about now for about the coming 20 minutes. And who has to do this inspection? Well, that's also depending on the legislation by country. Let's say it has to be a qualified person, yeah, who knows about the different, let's say, discard criteria in its country. Like in Holland, it's going to be EKH. In Belgium, we have this Vincent SGS. In Sweden, you can see all these different inspection companies who are responsible. The UK and Italy, Denmark, France, and so on. For some applications, you're going to need an inspector of Lloyd's or Bureau Veritas. So that all depends on who is going to do the job. Yeah. Okay, let's talk about when. We're just reading what's written into the ISO 4309. Well, you see requirements covering the application of the country in use. In some countries, you have like tower cranes, you have to do it every 6 months or every year and so on. So it depends a little bit on in which country you need to apply your discard criteria. The type of crane and the environmental conditions in which it operates. Is it a container crane or is it a tower crane or something? You also have to look into the classification of group of mechanisms, how many times you're using the crane, the loads, are you always going to up the, let's say, the maximum load and so on, yeah. You're going to look into previous inspections because you have sometimes a history of a crane, so that is important. The experience from different inspections or the experience you're going to have with comparable cranes, yeah. The length of the time the rope has been in service. If you see a discard coming up, then perhaps you need to move on in your number of inspections and the frequency of use. Sometimes a crane has been used not so often, but the last months or the last years, you're going to use it more often. So then you have to increase the inspection time. Yeah. Okay. So this is when. What are you going to inspect? Well, there are several modes of inspections you need. You're going to first count the broken visible wires at the outside. So this is a visual inspection. So you're going to look for fatigue wire rope breaks. You count them at the outside. Or you can lose the metallical area. You can measure that by, let's say, visually measuring the diameter of the rope, the decrease in rope diameter. You can also look for broken wires at the inside, but you can do that then later on with Bruno, with magnetic rope testing. You look for fracture of strands, you look for corrosion, you look for deformation, you look for mechanical damages. Sometimes accidents can happen, or you look for heat damage, like electric arcing that could damage the rope. So you need to inspect the whole rope length and also the terminations. You look at the sheaves and also at the drum. So don't look only at the rope, you look at the whole, let's say, application situation. So and who? Well, once again, it has to be a competent person, knowing his things about inspection, has, let's say, experience in it, or has the knowledge, or has acquired, let's say, the learning of how to do this very important exercise in safety. Okay, now let's talk about the visual inspection. So we're going to look outside the ropes, and then we need to have some discard criteria. We're going to look at wire breaks. Second discard criteria is the reduction of the diameter and wear of the rope. You have sometimes corrosion, not often, but it could be important in some cases. And you could have some deformation of ropes running around sheaves. They could have been shocks or something. Let's look into that closer. So the first criteria are the wire breaks. Yeah. Well, you have this table in the norm, and this table will give you the discard criteria, the number of wire breaks you can have in your rope before you have to took the rope out of service. So the ISO 4309 has listed two criteria. You count the number of wire breaks over 6 times the diameter of the rope, and you count the number of wire breaks over 30 times the diameter of the rope. Yeah, as you can see there, I have in the picture some wire rope, and you see here and there, you see some wire breaks. Yeah, so you count them over 6 and over 30 times D. Yeah, as you see on the picture on the right side, yeah, there are too many wire breaks in one strand, so that will be discarded immediately. Huh? But if you have normal wire breaks all spread it over your rope, then you just count them over 6 and over 30 times D. Yeah, and then you look into closer in your table here, the discard criteria. On the left, this is the rope category number. So every type of rope has been classified into the rope category number. What is the rope category number? Well, that's easy. It is the number of load-bearing wires in the outer layer of the strands of your rope. So if you have a 6 or 8 or 9 or 10 stranded rope, you just look how many wires are there in the outer strands. Right? So for a 6 times 36 standard rope, you're going to end up with 216 wires in your outer strands. So it's going to be between 201 and 220. Your rope category number will be number 9. So in the table, you look at number 909. That's the rope category number. The second here on the green part is just for ropes running on classifications of applications M1 to M4. Yeah. And on a single layer drum. So you have a rope running on a single layer drum. Yeah, then you have to look into the green part. Yeah, and into green part, you then have a classification for ordinary lay. You remember I explained what ordinary lay is, or Lang's lay. Yeah, and then in ordinary lay, you have the numbers of wire breaks till discard over a length of 6 times D and 30 D. Yeah, okay, and then we have the red part, sorry, the blue part. This is for rope running on multi-layer drums. Yeah, also divided in ordinary lay and Lang's lay, and this is for all classes of applications. So let's do an exercise now. You have, for example, 6 times 36 with inner wire rope core. Yeah, well, the rope category number, as I explained, is 260. You just look only at the outer wires, at the outer strands. So we have 260 strands. That mean in ordinary lay, we have number 9 there, yeah. And then we look into the green part. We have 9 ordinary lay, 9 wire rope breaks, yeah, in 6 times D, or you could have 18 wire ropes broken in your outer strands over 30D. So if you have 6 wire breaks, then you're okay. Yeah. If you have 9, then the discussion starts. You're gonna have to foresee a discard. Yeah. And you look at what is happening first, or 6 times D or 30 times D. Yeah. If you don't have these numbers of wire breaks, then you don't disclassify your rope, you can go on with it. Okay, so this is what has been put up as discard criteria for the number of wire breaks in your rope. Okay, there are some footnotes into this norm. You have to look into that closer. The most important one is the footnote D. Twice the number of broken wires listed may be applied to ropes or mechanisms whose classification is known to be M5 or M8. So you can double up the number of broken wires before discard if you have an application which has a classification of M5 to M8. Yeah, so you double up the figures. Yeah. Very important also that this norm is written for ropes running on steel sheaves. Yeah, there is no norm. Perhaps we're going to invite one, or someone is coming with it for plastic sheaves. So this is all done for steel sheaves. And I put some pictures next to it. There you see on the right side, you have, of course, this example for immediately discard if all these wire breaks come in line in one strand. Yeah, this is prescribed in all these footnotes where you have to look into that closer. Okay. So let's see about some types of wire breaks. A wire break can look like this. It's a Z kind of break. This is all fatigue. Yeah. It can look like this, a conical break with, let's see, in type A there in the picture, that's a diameter reduction and break. It looks to us that is due to overload, yeah. Or you can have a break, shear break, let's say, where actual load and compression of wire, and then the wire is fatigued and get out of norm, yeah, okay. Some examples, it could look like this. You see, these are all fatigue breaks from wires. You can see some Z-formed wires. This is all normal fatigue in your rope. Also here, sometimes you see 3 in a row. So you just count them. If you exceed the number in the table, then you have to discard your rope. Some more examples. Yeah, it adds up. Okay. Now, what I would like to talk to you about now are these kind of wire breaks, and these are completely different than the one I showed you in the slide before, because here you see long type of wires, and this is what we call internal valley breaks. Sometimes it's very difficult to find them, so you have to flex the rope, or you have unload the rope just to look into that closer. And these are types of breaks which, as you can see on the right side, breaks of wires between the strands and underneath the strands. And it's sometimes very difficult to find them, but these are completely different type of wire breaks. If you see 2 of these wire breaks, you have to put the rope out of service. So you have to discard them immediately, because if you're going to open up the rope, you're going to see that everywhere you have such long broken wires coming from, let's say, underneath. And that means that there are much more wire breaks than you can see with the eye. It's underneath. And if you open up the rope, you're going to have a little spaghetti like this. And if you open it up, you only have little pieces of wire. So you have no more rope anymore. So this is very important to distinguish valley breaks. Yeah, 2 valley breaks will give you discard. In real, it looks a little bit like this. So this is, let's say, disaster. Yeah, and you're going to see that these kind of valley breaks need to be inspected thoroughly, and then you normally have to get quickly to change your rope, because this could go to a completely break of the whole rope. Some more examples of internal valley breaks. So it starts and it can go very quickly. So be careful with valley breaks. That's the underneath situation of strands with valley breaks. You see they're completely, and then there's an indentation, yeah, and then things starts very quickly. You don't have any more wires which support the strand. And that's the situation of the inner core, wire rope core, which, as you can see, is completely distracted. So internal valley breaks, sometimes different to investigate, but be careful. Okay, how can you avoid these things? Well, we talked about it in the last seminars. You can do a type of rope with plastic infill, yeah, or you can do wires or strands which are compacted. Yeah, so then you normally avoid such internal valley breaks. Some more examples of wire breaks. Well, just be sure it could look like that. This is a Langsley rope, no problem with that. You see there's a lot of contact with sheaves and drums. So the more contact, the more I like it, because then you have less contact pressures, so no more wear in your rope. Very nice round rope, yeah. Okay, it can look like this. Then you have, yeah, some wear, but you see some material is gone, yeah, but the wire still intact, let's say, no wire breaks, so no problem there. And then some months later, you're gonna have a wire break. Looks like this. Okay, you have one, you count one, and then you count, months later, you count more, and you count more, yeah. And then it looks like this, and then, yeah, okay, you can see in this kind of situation that there are strands which have wire breaks, and there are strands with no wire breaks. It could, yeah, lead you up to the conclusion that there is an uneven load distribution on the strands. So sometimes when you look into the type of wire strands and the number into the strands, you can investigate further to see where this is coming from. Yeah, okay, that's for wire breaks, visual wire breaks at the outside. Yeah, discovering internal breaks. This is what's going to be explained later on by Bruno with the magnetic rope testing. I just show you some pictures how this is done, and then Bruno will get on this in detail in 10 minutes. Stay tuned. Yeah. Okay. Second discard criteria is the diameter reduction. As I showed you, there is wear on the outside of your rope, and okay, you can measure your diameter, and if the diameter has gone under what is figured here in this table, then also without wire breaks, you need to discard your rope. You see in the table 3 layers. You have single layer rope with fiber core, yeah, so with fiber core. Second is a single layer rope with steel core, yeah, or parallel closed, so let's say a fully steel core. And the third is the rotation resistant ropes, you know, where the core is inverted. Yeah, okay. So what you do, or what we did before, it was without discussion. In the old norm, there was written, if you have a wire rope with fiber core, and you have, let's say, a reduction of the diameter minus 10%, also without wire breaks, you discard the rope, because wire breaks will come easily. Yeah. If it was with steel core, you had to discard it when you have a reduction of 5%. But this was the old type of ropes. There are now more modern constructions, high performance ropes like 8 strand, 9 strand, 10 strand, compacted plastic infill ropes. Yeah, you can't normally you can't normally have a reduction of 10% or 5% in these ropes, yeah, because they are all compacted without, let's say, wire rope breaks. So in the ISO, the new ISO, there has to be a changing of measuring the diameter reduction. What you need now is to put these kind of measuring into the formula that is written there. It is a uniform decrease in diameter as a percentage of the nominal diameter. What you do is you measure the diameter, what it is now. You go back to a reference diameter when the rope was new, yeah? So sometimes you have a possibility to measure the diameter of the rope when it's new, like to the dead part where the rope is mounted on your installation, or just next to the end fitting. Yeah, if you don't have that, you could use the tolerance of the rope from the manufacturer. So let's say the nominal diameter plus 3 or 3.5%. So you put that into the formula and you end up with the reference diameter minus what you are measuring now, yeah, and you divide it by the nominal diameter. So the nominal diameter is what it was designed for, like 20 millimeter rope. Okay, you put it into the formula, you multiply it by 100, and then you have, for example, 6%. 6%. You look into your table, you have a single layer wire with steel core, yeah. So 6%, and then you look. It's between 5.5 and 6.5. This is a high discard. Let's say you're at 60% of your discard of this rope. Yeah. If you're up to 7.5 and more, then it's immediately, without even one wire break, it's completely already discarded. Then you have 100%. Yeah. So this is the diameter reduction. Yeah. Third criteria would be rusty situations. Yeah, certainly when you have ungalvanized ropes, yeah, you're gonna have, let's say, one of these types of corrosion. And why use ungalvanized ropes? Well, sometimes it's 8% cheaper to use a rope, but be careful, you're gonna have a rusty situation in the end of your rope. These are some examples from different kind of corrosion. You have external corrosion, you have internal corrosion, and you have fretting corrosion. Read what is written there and see some examples here. So sometimes you have this situation that your corrosion will end up with a high 60% or sometimes 100% to discard. Yeah. Okay. That's about corrosion. We have deformations, sometimes due to accidents, shocks, turning situations in sheaves, fleet angles, which are extreme, and then you can end up with things like this, and it's all prescribed into the norm also. We have some examples. Decrease and increase in diameter. You have waveness sometimes in ropes. You have bird cages coming. Core or strand protrusion or distortion, loops, kinks, flattened portions, or damage due to heat or electric arcing. So this is prescribed also. It will lead immediately to discard. Yeah. So what you need to do now, if you've done your inspection, you had to add up these things. You have to look at how many wire breaks in percentages. You have to look at decrease of diameter, and eventually, if you have corrosion, you have the external corrosion. And so you add up these percentages, and you come, like you see in line 4. You see, okay, we are at 80%. And then you could inspect more frequently. Yeah. If you have more than 80%, then discard normally your rope. Yeah. It's a little bit, let's say, in the fingers to the inspector itself to be certain to go on with the rope or not. There are 2 special discard criteria for elevator ropes. I'll just show you. They have their special discard criteria because it's a special application. Yeah, you see there's the ISO 4344, or you have to look it up in the different countries in Europe. And there's also a special discard for slings or grommets. Yeah, You see the numbers there, 4 or 6. You just do the examination on 3 times D, 6 times D, 30 times D, where you have the flexible part in your rope, and it depends, or you have slings from standard rope or for cable leather rope. Well, that's it for my part of the visual things you can see outside and do the discard. And I now go over to my colleague in Italy, that's Bruno Vicini, and he's gonna learn you how you can look into rope. Hi, good morning, Bruno.
Good morning to everyone. Nice, really nice to be here. Well, thank you very much for your participation in this really important educational moment. Well, my name is Bruno Busini, the managing director of EMC Instruments. I'm basically an electrical engineer, and I'm specialized in low frequency magnetic analysis and wire rope inspection technique. Well, first of all, I would like to focus on table 1, the same that Aaron shown before. Well, this table defines the modes of deterioration and the related assessment methods to be used for the periodic inspection that we must never confuse with the daily inspection. That is completely another thing. The periodic inspection must be performed by expert personnel who must necessarily evaluate each of the deterioration modes indicated in this table. If we want to apply the standard, we cannot ignore the possible presence, for example, of internal wear, even if we do not see it looking at the surface. If we do not write nothing on the report, we have to know this. It means that we are saying that there is no wear inside the rope. This is one of the various reasons why the standard introduces the magneto-inductive method, also called here in this regulation AMRT. Of course, it will then be up to the expert inspector to decide whether to use it, whether to open the rope locally with clamps, or whether to rely on a visual analysis, sometimes knowing that it will be impossible to quantify the problem. When the technician decides to carry out a visual inspection, he relies on a measuring instrument, unfortunately not always equipped with a calibration certificate, which is his own eye, together with a caliper and gloves used to touch the rope, only when the rope is stationary, of course. We can ask to ourselves, is this kind of analysis always enough? It depends. In this really interesting slide, we can see a result of a test carried out by OITAF. OITAF is the International Organization for Transportation by Ropes, in which a number of expert technicians were asked to visually detect a series of external breaks on a cableway cable. These are external breaks. Of course, the rope was not stationary in this case, but it was moving at a limited speed, at 0.3 meter per second. This is to try to simulate the real inspection conditions in which it's unthinkable to analyze the rope centimeter by centimeter by continuously stopping the plant. We know well that it is also necessary to make considerations related to the inspection time, and it is unthinkable to make the inspection phase of a rope last 2 or 3 days. It can be observed that on average, the single broken wire was detected 25% of the time. This means that in a real application, it's possible that 3 out of 4 broken wires are lost. This percentage is increasing in the case of multiple broken wires that are easier to be detected, wear, corrosion, and so on. This makes us think that even the identification of external problems can be affected by errors, and the human eye as well as attention are not infallible. Imagine carrying this case in a good lifting environment with problems of space, lighting, presence of lubricants, grease, and we will understand how it can be difficult to perform an accurate, even superficial inspection of a wire rope. when we talk about external defects, in fact, we often imagine macroscopic problems, such as those indicated in this slide. In reality, when we meet this kind of defects that you can see here, the rope is already in a really dangerous condition, and this is necessary to replace it immediately. This is not what we are looking for. Of course, we need to identify breaks before they turn into a high risk situation. When we operate in real environments, we are often dealing with a lubricant with limits the possibility to visually see breaks on the surface of the rope. We are also called to identify valley breaks that, as Alan told before, are really, really dangerous. As Alan told, if we found 2 valley breaks in 600 diameter, we have to change the rope. Furthermore, we often operate with non-rotational wire ropes, for which it's known that the most of the breakage are internal. In this case, when we observe problems from the surface, it may be already too late. So, there are many cases in which the pure visual inspection begins to become not enough, let me say. This is the reason why it was decided to introduce in the ISO 4309 standard the possibility to use a methodology called AMRT, that stands for Magnetic Rope Test, able to help the inspector in the difficult search and assessment of the damage. This methodology, in addition to being already mandatory in some cases, for example, in the ropeway sector, in some countries, this is absolutely mandatory. It's claimed by a series of international and local standards, and is globally known. For example, here we can see some standards that mention the AMRT technology. This is a mature and technical appreciated methodology that has already been used in our sector, the lifting goods sector, for more than 30 years, more or less. Here we can see a short video that illustrates how the methodology works. So we can start the video. Just 1 second. Okay, so now I will move a little bit faster when we can start to see the various figures. So here we can see a tool, a magnetic rope test device, in this case for ropes up to 65 millimeters in terms of diameter, that is ready to be used. Now we will see the physical principle that stays behind the methodology on a really general way. The system open, the rope fits inside the device itself, and then the device is closed around the metallic wire rope. Of course, there must be a relative speed between the rope and the device itself. So, or the rope moves or the device moves on the rope. There are some permanent magnets normally that force a very high magnetic field inside the wire rope. Well, when there are no defects inside the rope, all the magnetic flux moves in a certain way without any kind of leakage fluxes. Okay, and on the diagram that the system allows to obtain, there is only a little noise due to the fact that the rope is not a cylinder, but is made of strands. Okay, so now, sorry. Okay, perfect. Come back to the previous point. Okay, so now when a defect appears, as we will see after, on the right part of the rope, there will be a deviation of the magnetic flux lines, as you can see from this picture, that creates on the graph a certain signal. This signal is used by the expert operator to identify broken wires, corrosion, and something like that. Of course, as any other measurement system, also the MRT is subjected to international regulations. In particular, here, there is a regulation named EN 1297 that defines an acceptance criterion, which consists of the ability of the system to detect internal defects characterized by a very, very little section variation. In general, this section not exceeds the 0.5% of the total section of the rope. It is essential, from my personal point of view, that the technician that decides to use this technology does it with certified devices. Also, if this is not strictly mandatory, if we have to be honest in our environment, because we have to be sure about the fact that the system must be able to recognize also internal defects. This is absolutely important. Well, coming back to the methodology, the output of an MRT system is a graph, which must necessarily be interpreted by an operator. Of course, the ISO 9712, that is the regulation that stays behind the NDT methodology, defines the requirement of the personnel involved in a non-destructive test. And it would be good, although also here this is not strictly mandatory in the heavy lifting sector, to have such this certification, because this certify our degree of experience in the method. Just for a reference, in the cabway sector, in some countries, such as in Italy, this certification under the ISO 9712 is strictly mandatory to perform tests on the cable. Anyway, the graph obtained by the system is the exact photograph of the condition of the wire rope, and this is possible to highlight broken wires, wear, corrosion, distortion. Everything is repeatable, and therefore, if the test is carried out by two different technicians, the results will always be, of course, the same. And everything can be kept for future analysis and compared with acquisition made, for example, in the past 1 month ago, 3 months ago, in order to highlight not only the presence of the defects, but also the evolution of the defects, because also this kind of thing is extremely, extremely important. From this point of view, the methodology is extremely powerful, and a periodic comparison with the result obtained from the previous test can be used to estimate also the residual life of the rope. Through an accurate analysis of the rope status is in fact possible to predict when the rope will need to be replaced, increasing both safety, that is extremely important, but also efficiency. Some extracts from the standard that make us understand how important the MRT method is. Well, in this slide is noted that in the case of internal corrosion, the regulation states that without an MRT analysis, this is to be considered as qualitative, and this is obvious. In the same way, the emphasis is placed on the fact that when we talk about non-rotational wire ropes, there is the possibility that the most part of the defects as internal, and so an MRT is strongly recommended. It is clear that the expert inspector then will take responsibility for accepting these recommendations or not, justifying himself from time to time with his own technical, scientific consideration. This slide is interesting because it describes the old procedure that the regulation suggested up to the previous version. So now this is the procedure for opening a wire rope through the clamps. This technique was the only one available in the previous version of the standard. And today, this is indicated only if the MRT is not possible. The same standard emphasizes that this practice can be harmful to the rope, and as can be imagined. I never tried to open a 64 millimeter wire rope when this is in an operational way. So also is not physically feasible sometimes. Of course, after introducing the methodology, the standard also introduced a reject criterion, so a discard criterion. In this case, the discard criteria is in terms of loss of metallic area detected by a correct interpretation on the diagram. As can be seen, the indicated values are higher than the ones that can be found in the case of external defect. This is obvious because through the MRT method it is also possible to detect internal breaks that can be more together with the external. This is a higher number than only external defects. Just some words that is absolutely important. The best technique available today for the analysis of the rope is the combination of visual inspection and MRT inspection. In recent years, after this standard has been released and in this new version, we have seen a kind of competition between these two techniques. Someone told that the MRT was the only and the best. Someone else says that the visual is the only and the best. There must be no competition, but collaboration. So the visual alone has a lot of limits. Magnetoinductive alone has its own limits. The combination of these two methods allows you to have the full control of what is happening and to fully and clearly analyze any kind of problems. Just a couple of examples. Here, we were on an offshore environment with a non-rotational wire rope that externally was perfect. Okay, no external defects. So we found this graph that you can see in this picture that reveals that this rope is completely broken inside. So we removed immediately the rope, and here we can see the results of a breaking load test. Nominal breaking load 400 kilonewton. This rope break at 125 kilonewton. Extremely risky situation. Another interesting test on a little wire ropes used on a particular environment. In this case, the rope was full of broken wires, but this kind of wires were not so easily visible. Also due to the fact that the rope was not so easily reachable, let me say. So by using an MRT, we can see that this rope is completely to reject, and we did it. As a final slide, some defects, visual defects, so it's possible to see it without any kind of problems. We identify this kind of problematics by using MRT technique. Imagine how difficult it can be to detect a little valley break here in this rope when you have to inspect 3 kilometers of rope, and you have to do it in 24 or 36 hours. So MRT is absolutely useful for external defects, for internal defects, but it's absolutely useful also for external defects. Thank you very much for your attention. Michel, I leave you the word to you.
Yes, welcome back again. Thank you very much, Alain and Bruno. We would like to show you the coming up webinars. I think we will have one left for this year, will be around regarding rigging arrangements, sheaths, drums and blocks. And I think in Q1 we'll do lubrication of wire ropes and terminations. And maybe then we'll see of course, some other topics. So if you have any topics, please let us know. We will send you an evaluation form as well, where you can share your ideas. For now, we have a couple of questions received from you. Thank you very much. This is a question for Alain. What about ropes traveling over plastic nylon sheath? Is the discard different?
There is no norm till this day which can be written or which can be used. So it is all now the responsibility of your person who has or who has not experience in it. What we have seen is that if you have plastic sheaths, then normally the number of wire breaks are gonna be less than expected. So all these wire breaks will be on the inside, I think. Fatigue will be on the inside of your rope. And sorry, there is no norm still this day developed for plastic sheaves. And sometimes people are saying you have to use plastic sheaves because your rope will last longer. Yeah, it will last longer because you can't see the wear, or the plastic won't wear out your rope on the outside. It will wear out your rope on the inside. And that is a different situation. And sometimes it's dangerous. So a lot of accidents did happen on offshore islands. Why? Because they thought the rope was still okay. There were no visible wire breaks on the outside. And there were complete accidents. And so they decided, don't use plastic sheaves in the offshore business. So it is forbidden. No plastic sheaves in the offshore business. Yeah. So imagine that we were waiting for more experience in this type of plastic sheaves. And in most cases, you change the plastic sheaves together with the wire ropes, or you change the wire ropes together with your plastic sheaves. Yeah, that's what I can say at this day about plastic sheaves. So there is no norm. Be careful and wait and see if the ISO can start up a special norm for sheaves. All the things I've been saying, all the things written in the ISO norm, you look it up, it's only for steel sheaves. Yeah.
Great. Another question for you, Alain. It's not a question, but it's a comment, I think. 2 valley breaks on 1 lay length.
Yeah, if you have 2 valley breaks, normally you're going to have some more, let's say. Sometimes it's difficult to find them. Sometimes you have to unload the rope, yeah, put the block on the ground, yeah, and then flex the rope to see if you're bending the rope, that internal valley breaks appear, yeah. But if you have 2 of these valley breaks, it is normally discard immediately. So that means that something is happening inside. Yeah, it's happening underneath. There will be indentation. There will be contacts between your outer strands and your steel wire core. Yeah, and this can go very quickly. Yeah, so normally 2 valley breaks, it's finished. You just have to proceed to change the rope. Yeah. And if it is on 2 times diameter or 3 or 6 or 30, it doesn't matter. Things will continue, and it gives you an idea about the badly situation inside your rope, underneath your strands. So valley breaks, take care of them, discard immediately. Yeah.
Okay, again, one for you. I'm sorry, Bruno, but again, for Alain, what could cause valley breaks?
Well, it can be caused, and let's be honest, it is not always the fault of the rope. It is the fault of your installation. Drums, grooves in sheaves, which are not correctly when you put the rope in service. If the rope is squeezed into the too small groove in your sheave, then you end up with this kind of destruction inside. And the first destruction you're gonna meet is, okay, indentation, because you're gonna squeeze the outer strands onto the core, and you will end up with this type of valley breaks. So mostly this thing will come from grooves which were too tight from the beginning. Yeah. So take care of your sheaves, grooves, and measure them up. We explained it. It have to be 5% more space into your groove than the nominal diameter. Yeah. And how it comes? Well, you have your rope diameter. Let's say you start with 20 millimeter. Yeah. But you have wear on your rope on the outside. Material will disappear. Yeah. And you end up, when you have your rope completely fatigued, you end up with, let's say, 90 millimeters. All the time your rope is 19.5, going down to 19. It has the ability to wear out your groove of your sheave. So when the rope is discarded, your groove will be 19. And then you come with your new rope, which is 20. And normally it isn't 20, it is 20 plus the tolerance of the manufacturer. So it's going to be 20 plus 3 or 3.5%. So let's say it's 20.7. This will be squeezed into a groove of 90 millimeter. You're going to end up with the rope. You're going to using it like, let's say, squeezed in. So the groove will be opened up again to 20 or something, but bad things had happened inside. Yeah? And if I come to measure your groove later on, I'm going to measure 20, but not 19 like it was before, because you ended up with freezing it out with your new rope. And this will end up with wire breaks in your rope on the outside and on the inside. And when it's on the inside, it normally can look like valley breaks. Yeah. So mostly of the time, it is due to your bad grooving on drums or especially on sheaves.
Okay, great. I have one for you, Bruno. Can MRT help me to find external broken wires?
Yes, absolutely. Yes, the MRT is able to detect both external and internal broken wires, because the effect in terms of leakage flux are more or less the same. So the answer is it is absolutely allowable to detect external broken wires, but also corrosion, also wearing. The only thing that the MRT is not able to detect is a decreasing in terms of diameter of the rope, especially when it is smooth. I mean, because if you have a very let me say, a decreasing in terms of the diameter that is immediately in a certain zone, then maybe the diameter passes from 20 millimeter up to 19 millimeter. This creates also a sort of distortion on the rope itself, and this leads to a diagram, a certain kind of graphs. While if the decreasing is very, very smooth, the system is not able to detect. But it is also used, for example, to detect the effect of lightnings, because there is a changing in terms of metallic material properties.
Okay, I do a final question. We have lots of more questions, but we're running out of time. So I do one more for you, Alain, again. Hopefully a lot of MRT questions will come up after. This one is interesting. Are there any specific requirements for nuclear working environment ropes?
Well, that's a special division, of course, yeah. So nuclear plants will have safety factors of about 10 or more, and the inspectors there, yeah, they're going to be specialized in this kind of stuff, yeah. So let's be honest, I can't tell you anything clearly about what's happening in nuclear plants. We're going to discuss it later on with end terminations, because end terminations with nuclear situations there is also discussable. Yeah, but this is done by specialized people, and of course, if one wire break is a disaster there, they're going to discard it immediately. But be careful in nuclear plants. The frequency of hoisting there is normally very low, or in special situations, severely checked and double checked before they do a hoist. Yeah, that's my opinion about that. Okay.
Okay, I do one last one for you, Bruno, and maybe you can respond to the answer from Alain as well. But I have one for you. Can we say that MRT is more accurate than visual inspection? Does the ISO 4309 more than recommend the MRT? So
yes, well, it's not true that the MRT is more accurate. I repeat, the union between these two techniques is extremely accurate. There are things that with your eyes you cannot see. There are things that you can see if you conduct the visual inspection in a certain way. I always say that a visual damage is not visual because in this moment you can see it. It's visual because it can be seen by everyone. The amorti is an help that can be used in order to detect everything. Then, of course, you can go there seeing by your eyes. In some other cases, the amorti is the only way that you have to use it. Another consideration, just 1 minute, a regulation does not say you have to do it. We discussed it along on the ISO commissions. A law says you have to do it. A regulation gives you all the recommendations that you must follow to be compliant to the regulation itself. It cannot be said from a regulatory point of view, you have to do it. This is the standard. This is the status of the art. The amorti is the status of the art.
Okay, thank you for your answer. It's 12 o'clock. We need to close up. All the other questions will be answered in the Q&A and will be sent to you after this session. Also a record of this, so you can see it afterwards. You can share with everyone you want. And of course, we will send you an evaluation form, so please fill in, and so we can have more webinars coming up. And please have a look at our socials and communication channels for the next coming up webinars. Ellen, Bruno, thanks very much.
Bye-bye, everybody.
Thanks for joining. Bye-bye.
Thank you. Bye-bye.
For the attention. Bye-bye.
Bye-bye.